Welcome to Education Express. Last time we finished with exercise 4A. These are the extra important questions, extra questions you can say, in connection with exercise 4A. I sincerely request you to go through the formulas, memorize them, practice them, and involve actively in solving the questions by applying those formulas. Repeatedly, I had been advocating usage of formulas. I had given you very limited number of formulas, and if you work on it, they will help you to do multitasking also. Those formulas can be applied in most of the questions, though they are very limited, but they are very powerful. Now here, these are the 6 questions which I have listed away on the board. I'll be solving them by using those formulas only, so that you understand and start building trust and faith in those formulas. Excuse me. A plus b the whole square is a minus b the whole square plus 4ab. Very important formula, very important result. This formula you must understand objectively. Connect the relationship between a plus b, a minus b, ab. Out of 1, 2 and 3 things, 2 will be given to you in the question. So the third one can be obtained with the help of this formula. Similar application of this formula, look wise they look different but same analogy. A plus b square equals to a minus b square plus 4 a into b. A into 1 upon a will give you 1. So that's going to remain the same. One must understand that these formulas are sincerely very important. And I'm sure if you make use of it, life will become a little more simple. It will be a life of convenience. You will get most of your answers correct. See how I'm going to do the next 6 questions by using the same formulas. Please may have your attention. A plus b equals to 7, ab equals to 6. You have to find the value of a minus b. So we use a plus b square, a minus b square plus 4ab. Substitute the values. 7 square equals to a minus b the whole square plus 4ab, that's 6. 49 equals to a minus b square plus 24. So a minus b square happened to be, I am shifting this 24 on that side, becomes 25. Therefore, a minus b will be plus or minus 5. Remember, whenever we are taking a square root, you will get 2 different options of plus and minus. Second part of the question is find out the value of a square minus b square. We know the identity a square minus b square is a plus b, a minus b. What is the value of a plus b? 7. What about the value of a minus b? Minus 5. So the product is minus 35. Enjoy. I hope you can understand and gauge the significance of the formula which established the relationship between a plus b and a minus b. What about this question? A plus b is 11, ab is 13, find a minus b. Again I am going to use the same formula. A plus b the whole square, a minus b the whole square plus 4ab. Substitute the values. 11 square equals to a minus b, no idea, plus 4ab, that's 30. 121 equals to a minus b the whole square plus 120. So a minus b the whole square would be 1. Therefore a minus b would be plus or minus 1. Square root of 1 is 1. So you found out the value of a minus b. Isn't it simple? Isn't it easy? I'm very sure you will definitely gain a ground with respect to these questions. Here they have given me x square plus y square equals to 37, xy equals to 6. So we don't have x plus y, x minus y, so I'm not going to use this formula. Not possible, because I don't have x plus y or x minus y. What do I have? X square plus y square. Which formula will have x square plus y square? Sir, you can use x plus y the whole square as x square plus y square plus 2xy. Knowing the formula is not everything, but application makes its purpose 100% success. What is more important ideally is what formula to apply where. Having knowledge of the formula is one thing, and applying those formulas for the right purpose is another thing. We need the blending of both the things, and that can be developed only and only by practice. Once you keep on practicing the formulas, you will understand from the nature of the question. You will be able to interpret what is required is better interpretation. Your better interpretation will help you to explore, enrich, evolve, and have a good dominance on the subject. For that purpose, knowing the fact that in last two questions, I have applied a plus b square equals to a minus b square plus 4ab, because a plus b and ab was given to me. Whereas over here a plus b, that is x plus y, not available. X minus y, not available. Using this formula would have no help to me. What do? I need to search for a formula which can contain x square plus y square and xy. I think this is a perfect formula which has combination of all the things that is needed. Kindly apply. X square plus y square 37 plus 2 xy 6. 37 plus 12, that makes it 49. Therefore x plus y, taking square root on both the sides, will give you plus or minus 7. Fantastic. So we are through x plus y. Now we are interested in finding out x minus y. How do we find out x minus y? Again, recollect what I said. Since x plus y is available, xy is also available, we have to find out x minus y. You can use that linking formula. So what is the linking formula? X plus y whole square equals to x minus y whole square plus 4xy. Most important thing that one must understand is that over here the value of x plus y is 7 and minus 7. So you can say when x plus y equals to 7 and when x plus y equals to minus 7. Two different values, so two different ways of solving the same question. How do we apply? Put the value 7 square equals to x minus y, we have no idea, plus 4xy, value of xy remains 6. Solve it. 49 equals to x minus y the whole square plus 24. Therefore 49 minus 24 will give you x minus y the whole square. Taking square root, x minus y would be plus or minus, this would be 25, square root of 25 would be 5. If I apply x plus y as minus 7, so minus 7 the whole square will be x minus y the whole square plus 4. That means I am using the value as minus 7 in this. But if you see, is there any need of doing this? My answer is no. So why no? Because since I have the value of x plus y the whole square is 49, and if I use that, there is no need for me to systematically apply the value of x plus y. In other words, if this is the formula, I can see that x plus y square is 49. So simply by placing 49, I can eliminate the working for plus 7 and minus 7. In short, this working is eliminated by your smartness. How so? So I am going to use this formula. We have the value of x plus y the whole square. So I will apply x plus y the whole square only. That's 49, and this is how I get my answer. So there is no need for me in this case to show the separate working for x plus y as minus 7, because I am not applying x plus y as 7 or minus 7. I am rather using x plus y square equals to 49. This is the formula. X plus y square is 49. 49 remains in its place, equal to x minus y square plus 4 into 6. And that's how I get the value of x minus y. So x plus y found out, x minus y already done. Next part, x square minus y square. How do we go about? X square minus y square is an identity for x plus y, x minus y. Kindly substitute the values plus or minus 7, plus or minus 5. Your final answer will be plus minus 35. This is your answer. This extra questions are given only for the purpose of building your confidence with respect to the formulas. All these formulas are new to you and you are using it for the first time. When you practice along with me, whatever questions I am doing, the same question if you practice at the same time, that will have a long lasting impact on your mind and you'll be able to absorb it slowly and gradually. Once it gets digested, it will become a repetitive process for you to apply them in more productive way. 3x plus 1 upon 3x is 8 and they expect me to find out 9x square. From my sincere approach, I can see that square of this will result in 9x square. So what I do is 3x plus 1 upon 3x equals to 8. So square would be 64. You shouldn't be in haste just to write the square of 3x plus 1 upon 3x square. Many people what they do is, sir, 3x plus 1 upon 3x, the whole square will result in this only. That will be incorrect because this is a plus b the whole square. That would be a square plus b square plus 2 into a into b. We have already discussed in our first class. Many a times we have done this. This will result in 9x square plus 1 upon 9x square plus 3x gets cancelled. What remains is 2, 64. So 9x square plus 1 upon 9x square will give you 64 minus 2 at 62. I hope it's very certain and clear with this. So question was very simple. The only thing is we need to handle with lots of discipline. Move on to question number 5. Question number 5. A minus b equals to 4. A plus b, since a minus b, a plus b given, you can use the linking formula, bridging formula. A plus b square equals to a minus b square plus 4ab. Same formula. Apply the values. 10 square, 4 square, 4ab. This will be 100 equals to 16 plus 4ab. 100 minus 16 equals to 4ab. Therefore, 4ab equals to 84. Therefore, ab equals to 21. You got the value of a. Have a look over here. A minus b, ab, a plus b. Again apply the same formula. A plus b the whole square would be a minus b the whole square plus 4ab. A plus b, we don't know. A minus b, substitute the value, plus 4ab, that's 20. 64 plus 80 gives you 144. Therefore, a plus b square equals to 144. A plus b would be plus or minus 12. This is how exactly we have done the extra questions. After this, let's move on to exercise 4D. This is question number 9, exercise 5D. My dear friends, we have finished with A exercise. These are the questions which are in sync with exercise A only. So, the idea is basically to show you that how the outlook of the question may differ, but yet the methodology that we are going to adopt for solving the question is going to remain the same. Have a look at this question. They have given us x equals to 1 upon x minus 5. We need to find the value of x square minus 1 upon x square. So, what we do is first bring it into a horizontal form so that the question becomes familiar to us. This is x into x minus 5 equals to 1. That is x square minus 5x equals to 1, which means x square minus 5x minus 1 equals to 0. This question is exactly identical to exercise 4A, question number 13, question number 12, identical. What we did there, sir, we divided both the sides by x. So divide both sides by x. What do you get? X square upon x minus 5x upon x minus 1 upon x equals to 0 upon x. This will give me x minus 5 minus 1 upon x equals to 0. What we need is x minus 1 upon x equals to 5. So we obtain the value. But sir, we have to find x square minus 1 upon x square. Yes, my dear friend, this is nothing but x plus 1 upon x. X minus 1 upon x. That is what we have to find. Of which we already found out x minus 1 upon x. I hope from here on you remember the linking formula, which states that x plus 1 upon x, the whole square, is x minus 1 upon x, the whole square plus 4. I told you also, this formula is intense, is important, extremely important, will be used in most of the sums. You must know this formula properly and its application as well. So what I'm going to do is, I'm going to substitute the value 5 square plus 4. That makes it 25 plus 4, which is nothing but 29. X plus 1 upon x, the whole square is 29. Therefore, x plus 1 upon x becomes, take the square root on both the sides, plus or minus square root of 29. So, we have value of x plus 1 upon x, x minus 1 upon x. We need x square minus 1 upon x square, which means this. So can I say x square minus 1 upon x square can be written as x plus 1 upon x, x minus 1 upon x. Please substitute the values plus or minus square root of 29 multiplied by x minus 1 upon x is 5, which gives me plus or minus 5 root 29. This question is very, very important. Move on to the next question, which is again very simple one. A square plus b square 34, ab 12. So if a square plus b square given to us, ab given to us, we can easily find out a plus b. We can also find out a minus b. How, sir? When we expand the formula a plus b the whole square, we get a square plus b square plus 2ab, which takes care of a square, b square, which is given to us, and ab. I told you, you have to apply the formula depending on the situation. So now, a square plus b square, 34 plus 2 times ab, 34 plus 24, that makes it 58. So you have the value of a plus b the whole square. What I have to find? 3 times a plus b the whole square. Then I have to find a minus b the whole square. Apply the formula. A minus b square equals to a square plus b square minus 2ab. Tell me what are the values of a square plus b square? 34 minus 2 times ab, that's 12. So 34 minus 24, which is nothing but 10.
1 minute.
So now, since a plus b square is obtained, a minus b square is obtained, what we are looking out for? 3 times a plus b square plus 5 times a minus b square. That is 3 times 58. 5 times a minus, that is 10. So this is nothing but 24 to 15, 17 plus 15. That makes it 224. I hope you guys will enjoy the lecture. Welcome to Education Express. We'll continue with chapter expansion. Expansion exercise 4C. Before we proceed, what are the formulas which will help you to solve the questions on 4C will be as follows. As we know that a plus b whole square equals to a square plus b square plus c plus 2ab. Same way, in case if we have 3 terms a plus b plus c the whole square, this can be expanded a square plus b square plus c square plus 2 into a into b plus 2 into b into c plus 2 into a into c. In short, if you have a plus b plus c the whole square, it will be a square, b square, c square, all plus. There is no question of getting any negative number, as it is a plus b plus c the whole square. So a square plus b square plus c square plus 2 into a into b plus 2 into B into C plus 2 into A into C. That is 2AC. In case if this would have been A plus B minus C the whole square, again it will be A square plus B square plus C square. Now after writing the first three terms which are square terms, so has to be positive, then we need to decide what exactly would transmit into the fourth term. It will be 2 into A into B, so it will be plus 2AB. After that 2 into B into minus C, so it will be minus 2BC. After that it will be 2 into A into minus C, 2 into A into minus C. So what we are doing is A square, B square, C square. 2 into A into B, 2AB. 2 into B into minus C, minus 2BC. 2 into A into minus C, minus 2AC. If you wish, you can write this as A square, B square plus C square. 2 common, AB minus BC minus AC. So we really know how to expand a square of three terms. Take another permutation, A minus B minus C the whole square. Write this as A square plus B square plus C square. Does not matter, my dear friends, whether the sign over here is positive or negative, because square of a number is always going to be positive. So A square plus B square plus C square. Now here on 2 into A into minus B. That means 2 into A into minus B will be minus 2AB. 2 into minus B into minus C. That will be plus 2BC. 2 into A into minus C, minus 2AC. As simple as that. Any permutation combination you try, A minus B plus C. Suppose in this permutation combination, again A square plus B square plus C square. After that 2 into A into minus B, minus 2AB. 2 into minus B into C, minus 2BC. 2 into A into C plus 2AC. If you wish, you can compress it by taking minus 2 as a common factor. You get AB minus, so plus, because plus into minus is minus. BC minus, because minus into minus will become plus AC. I will not ask you to mug up these formulas. You need to remember the technique. Supposing if you have A minus B plus C the whole square, how to go about? A square plus B square plus C square. Next, 2 into A into minus B, minus 2AB. Perfect. 2 into minus B into C, minus 2BC. Perfect. 2 into A into C, 2AC. This is how we are going to go about for our next exercise, which is 4C. I hope the formula for the purpose of solving the questions for 4C is very much clear. So let's move on to the question 4C. Here we go. Exercise 4C. X plus y minus z the whole square can be written as x square plus y square plus z square plus 2 into x into y, 2xy. After that 2 into y into minus z, that will be minus 2yz. And finally 2 into x into minus z, that will be minus 2xz. That is it. As simple as that. You need to simply apply the formula that we have discussed earlier. What about this question? First you write down a square. After that, irrespective of the sign that we have to always follow plus for the square sign. B square plus C square. In place of writing 3b, in case if you choose to write minus 3b, then also it's going to be the same, because when you expand, you are undoubtedly going to get a positive number only. So a square plus b square plus c square. After that, plus 2 into a into b. What is in place of a? 5a. In place of b, minus 3b. Plus 2 into B into C. B is 3B. This is C. Plus 2 into A into C. In place of A we have 5A. In place of C we have C. So now when you expand 5 square, 25A square. Minus 3 will become 9. B will become B square. C will become C square. Now here first multiply number to number. 2 into 5, 10. 10 into minus 3, that's minus 15. A into B, A, B. 2 into minus, so 5 square would be 25, 25 A square plus minus 3, so become 9, 9B square plus C square. 2 into 5, 10, 10 3s are 30, minus 30 AB. 2 into minus 3, that is minus 6, B into C, BC. And finally 5 2s are 10 AC. So I hope you guys have really understood how to expand a square when 3 terms are given to you. That means the sum of 3 terms and the square of that. Let us try this question. A, that is 5x minus 3y minus 2 the whole square. How do we go about? 5x A square plus B square plus C square plus 2 into A into B plus 2 into B. What is that place of B? Minus 3y into C minus 2 plus 2 into A, which is 5x into C, that is minus 2. How to go about now? 5, so 25x square plus minus 3 square will be 9y square plus 4. 2 into 5, 10. 10 into minus 3, minus 30. X into y, xy. Remember, while multiplication, number will get multiplied by number and a variable will get multiplied by a variable. 2 into minus 3, minus 6. Minus 6 into minus 2, that's 12. Plus 12, y. 5 2s are 10. 10 into minus 2, minus 20. Minus 20, what remains? X. So, this is your final answer. If there are any like terms which you feel which can be added, no hesitation in adding them up. Alright, let's move on to the next question. X minus 1 upon x plus 5 the whole square. Again, we are going to treat this question exactly the same manner in which we have done the previous one. As we know, the formula a square plus b square plus c square. After that, plus 2 into a into b. What is there? A is x, b is minus 1 upon x. After that, plus 2 into b into c. What you have in place of b? Minus 1 upon x. And what you have in place of c? 5. Plus 2 into a into c. A, in place of a you have x, in place of c you have 5. So when you solve this sum, x square plus 1 upon x square, always positive, plus 5 square, 25. If you multiply this, x will get cancelled. What remains is 2 into minus 1, that is minus 2. Have a look over here. 2 into minus 1, that is minus 2. Minus 2 into 5, that is minus 10. Minus 10. What is there in the denominator? X. Remember, all the numerators will be multiplied together. So 2 into minus 1 into 5, that is minus 10. Denominator we had x, so we wrote x. So finally minus 10 upon x. What about this one? 2 into 5, 10, 10 into x, 10x. So this is our answer for this question. I hope slowly and gradually things are building up. Have a look at this question. It seems to be very simple. It's a question on expansion. X plus 8, x plus 10, x plus 10 plus 8 x plus 10. So what do you get? X square plus 10 into x, 10x plus 8x plus 80. X square, these two terms can be added, 10 and 8, 18x plus 80. So if you have a look at this sum again, there were like terms which would have been added. Have a look over here. X square plus 1 upon x square plus 25 minus 2 should have been 23 minus 10 upon x plus 10x. So this is to bring your attention to a fact that in case if there are any terms which are like terms which can be added or which can be subtracted, then that calculation will be a part of my answer and I need to do that calculation. I need to undergo that operation for the purpose of getting the correct answer. So if you see over here, if there were two like terms, how are you going to deal with it? So when we have two like terms, we are definitely going to either add or subtract depending upon the operation or the nature of operation. If we do this over here, 10 plus 8 becomes 80. In the same way, the like operations over 25 minus 2. We are sure that these two terms are not like terms, so we do not have any other like terms other than 25 and 2. So 25 minus 2, 23. In case if you leave your answer over here, teacher at its own discretion would surely deduct some marks. So you need to be very careful about this. Though it is very simple, but you need to be a little cautious about this. Alright, so I hope you are very clear with this. The formula that we did, let us see the application aspect of it. Question number 4. It is given to us that a plus b plus c equals to 12. A square plus b square plus c square equals to 50. And you have to find this. So first, let us formulate our formula. A plus b plus c, it's given to us, equals to 12. So can I say a plus b plus c, the whole square, equals to a square plus b square plus c square plus 2 into a into b, 2ab, likewise 2bc, 2ac. In place of a plus b plus c, can I substitute 12? Yes, sir. So this becomes 12 square. What is the value of a square plus b square plus c square? It is already given to us, which is 50. Can I take 2 common outside? Very much. So what we get? AB, BC, AC. So 144 equals to 50 plus 2 times AB, BC, AC. Shift this 50 on this side. 144 minus 50 equals to 2 times AB, BC, AC. What do you get over here? 94 equals to 2 times AB, BC, AC. That means AB plus BC plus AC equals to 94 upon 2, that is 47. This is your final answer. Have a look over here. Question number 5, which says a square plus b square plus c square is 35, ab plus bc plus ac is 23. They want to find out the value of a plus b plus c equals to how much? Solution. Again, since we have to find a plus b plus c, so a plus b plus c, the whole square can be written as a square plus b square plus c square plus same thing over here. A plus b plus c, the whole square can be written as this, plus I am taking out 2 common, that will give me AB, BC, AC. So this formula we are very much familiar with. Let us substitute the values. A square plus b square plus c square given to us as 35 plus 2. What is the value of AB, BC, AC? 23. 35 plus 46, that is 81. Since a plus b plus c, the whole square is 81, therefore a plus b plus c equals to plus or minus 9. My friends, remember, we discussed in our first lecture, if x square equals to 9, then the value of x will be plus or minus 3. If x square equals to 25, then the value of x will be plus or minus 5. Same way, if a plus b plus c, the whole square is 81. That means the value of a plus b plus c will be plus or minus 9. I'm sure you guys are enjoying this exercise. And trust me, it is very simple. Discipline yourself, follow the formula, practice the formula, Let's move on to the next 2-3 questions of this exercise. Let's move on to question number 7, which is again same type of question. A square plus b square plus c square is 50. AB, BC, AC is given to us. We have to find A plus B plus C. So can I say A plus B plus C whole square equals to A square plus B square plus C square plus 2 AB, BC, AC. What is the value of A plus B plus C? We yet don't know. What is the value of A square, B square, C square? That's 50. Plus 2 multiplied by 47 because AB plus BC plus AC is 47. 50 plus 47 2s are 14, 4, 1, 8, 9, 94. That makes 144. Since A plus B plus C the whole square equals to 144, therefore A plus B plus C equals to plus or minus 12. That is taking square root on both the sides. My friends, please do remember this step. Many students I have seen while correcting their paper, they simply write plus 12 and they ignore minus 12. Please don't do that. It's a very, very important part of it. Unnecessarily the teacher may deduct 1 mark or probably half mark for no reason, knowing the fact that we know the things that we are going to make a mistake. So please avoid this mistake. Again, same nature of question, as we know that x plus y minus z equals to 4. Can we square on both the sides? X plus y minus z, the whole square, when I expand, it will be x square plus y square plus z square plus 2 into x into y. After that, plus 2 into y into minus z. After that, plus 2 into x into minus z. Let's expand. X square plus y square plus z square. This will give me plus 2xy. This will be minus 2yz. That will be minus 2xz. And this will be x plus y minus z the whole square. Do we have the value of x plus y minus z? Certainly, it's 4. So 4 square. What about x square plus y square plus z square? 30. Substitute the values. Can I find 2 common? Yes, sir. So xy minus yz minus xz. So 4 square will come 16. 30 will remain as it is 2. Oh, we don't have the value of xy minus yz. xy minus yz minus xz. Can I substitute this 30 on this side? 60 minus 30 will give me 2 times xy, yz, xz. 16 minus 30 minus 40 equals to 2 times xy minus yz minus xz. We can certainly find the value of xy minus yz minus xz as minus 14 upon 2. That's minus 7. So this is your answer. I am sure questions pertaining to the sum of 3 terms and to find the square of that couldn't have been as simple as what we have done. It is one of the examiner's most favorite question, and almost each and every question paper will certainly contain one question at least on the sum of the 3 terms square. So in case if you want to find out the sum of the 3 terms square, you have to refer